lecture-1.
Okay, now we are in the question session of the Henry's law. After successful completion of the theory session and applying the theory part into the question and solving. Okay, now this is one of the beautiful question and previous examination question only. So how you have to apply that theoretical concept and solve this type of question. Okay, from this graph we have to arrange them in the increasing order or decreasing order of kh of O2. Okay, see here on the y-axis they have taken solubility and x-axis they have taken partial pressure. Okay, so for a given, let us take any pressure at your own pressure. Okay, solubility of oxygen is this one, nitrogen is this one, and helium is this one. Okay, so at a given partial pressure, the solubilities are different. I have given a beautiful logic. What is that? Higher the kh, lower will be solubility. Okay, here solubility of helium is lowest, so its kh will be going to be highest. So answer will be helium greater than. Second will be what? Nitrogen. Second, third will be what? O2. Okay. So this is the increasing order of kh. Okay. How to use this graph and how to use the theoretical logic, theory session logic and solving the question. Both are important. If you connect together only, then only there will be result. Is it understood? So I think this part, I think everybody is clear. Okay. So that logic also I have not made it. It is just made from this graph only. Okay. So already we know that P is equal to KH into X. Okay. Here solubility means X only. So we can write as a X is equal to 1 upon KH into P. What we can write? So solubility Y is equal to MX. I'm in another way I'm explaining. Okay. So you may think that sir gave logic and using this, but it is made logic from this place only. Okay. So here on y-axis solubility, x-axis partial pressure, slope, higher slope. Okay. So higher slope will be there when kh is lower. So this higher slope, lower kh. So higher slope, lower kh. Okay. Lower slope, higher kh. Is it understood? So this way also you can understand. I have given you both the explanation how to solve this type of question. So like this only I'm going to give you the question session immediately after the theory session. Is it understood? Okay, we will start with the next question. Be ready. Okay, we are into the next question. We are into the next question. If N2 gas is bubbled to the water at 293 Kelvin, N2 gas is sent into what? Water. So here we can use the Henry's law because gaseous solute and liquid solvent. How many millimoles of N2 would dissolve in 1 liter of water? Water is how much solubility into which we are going to find out is 1 liter. 1 liter can be taken as 1000 ml or 1000 grams. Okay. Why I am telling you at this condition? Because it is going to be useful while solving. Assume that N2 exert partial pressure of 0.987 bar and Henry's law constant is given. Okay. What are the things given and what we have to find out? I will just highlight it. Okay. In this constant, KH is given. What is this? KH is given. And what is this? P is given. Obviously, when you are given with P and KH, what you will find out? X you will find out. Okay. So X, after finding out X is the mole fraction. But answer we want moles. Mole fraction is equal to moles of the given substance upon total number of moles. For total number of moles, 1 liter of water, that means 1000 by 18, that is 55.55 will be the moles of water. Okay. So let us start with the solution. Are you ready with me? So two things are given. Sorry, three things are given. Moles of water 55.55, partial pressure of nitrogen 0.987, Henry's constant is 76.48. By using this, we are going to find out millimoles of N2. N2 we are going to find out. Are you ready? Okay, so according to Henry's law, what is Henry's law? According to statement of Henry's law, P N2 is equal to X N2 or X N2 into KH. Okay, so but I require here mole fraction of N2. These two things are already given. Okay, these two things are already given. KH is given, P N2 is given, X N2 I have to find out. So X N2 is equal to partial pressure of N2 divided by KH. And one thing you have to be very careful is units. It is kilobar it is given. Okay. So I have changed it into the bar. And this is already in bar. Make sure that mole fraction is unitless. So this unit and this unit must be same so that their both units get cancelled and you will get the correct answer. Okay. So on dividing this, how much I am getting? 1.29 into 10 to the power of minus 5. So x N2 is equal to 1.29 into 10 to the power of minus 5. Mole fraction is equal to number of moles of N2 divided by total number of moles. Here two people are there. Who are those two people? Nitrogen and water. So, but you can, with this idea, 10 to the power of minus 5, mole fraction is very less. That means number of moles of nitrogens are negligible in comparison to number of moles of water. That is what I have written here. N2 is very, 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 very less than the NH2O. Hence, what we can say 1.29 into 10 to the power of minus 5 is equal to Nn2 divided by NH2O. Is it understood? So, I have neglected this denominator part. Now cross multiplying Nn2 is equal to this much. You are going to get one more thing you have to be very careful is here question is in the millimoles. Nowadays integer type question with two decimal places are there. So this value matters 0.716. So in the if you're writing in the integer type question, what you have to write 0.72 millimoles. What is the answer? 0.72 millimoles. Is it understood? Second question is understood. So theory part is over and we have done two objectives, two questions. Like this, we are going to do some more beautiful questions. Stay with me. Keep noting down. Okay, we are in the third question, and all these are picked up from the objective only, but only thing I'm not going to give you options. Okay, so if you feel that you will try on your own, just to do a pause it on the screen and try it on your own, and after that you can forward it again, then you can cross check your answer. Okay, so these are the ways you should be interactive with the class. Once you noted down this question, you feel that I will give a try. Just pause it the video. Then what you will do? You will solve it. Then you cross check your answer with the just forwarding, fast forwarded. You can just push through that cursor to forward. Then you can cross check the answer. If it is okay, then you need not to listen to the explanation. I want that you should save your time. Is it understood? And then you can go for the next question. Next question also you are able to do. Then within fraction of minutes, you are going to complete all the variety of the question. These are all I have picked up from the various entrance examinations only. Or like second question was from NCRT. Like that, I am referring various books to check different models of questions so that you should not refer anything else. Theory lecture and question session, if you're perfect, then nobody can stop you from these topics. Is it understood? So let us start with this question. Solubility of pure O2 at 20 degrees Celsius and 1 atm pressure. Okay, so this is solubility is given. What is given? And per liter. Solvent is how much per liter. This is also plays a vital role. Okay, this also plays a vital role. O2 per liter when air is in contact with water. Okay, so solubility of oxygen is given 43 milligrams per liter of water. and air pressure, partial pressure of air it is given. So listen very carefully. It is not partial pressure of oxygen alone. It is a partial pressure of nitrogen, oxygen, various gases present over there. Okay. So this is, don't just take it as a P. P is something else that we are going to see it now. Okay. How much amount of O2 dissolved in 500 ml? There is one more latch over here. Okay. Given solubility is per liter and he is asking for 500 ml. How many technicality you have to know about the question? Okay. First thing is partial pressure is not given. Pressure of the total is given. For that, what you have to use? Dalton's law of partial pressure. Okay. So, and here we want the answer in for 500 milliliter, whatever is given per liter. Is it understood, students? Okay, then average concentration of O2 in air is. Okay, so let us see how to solve. Okay, this is the solution. Here, according to Henry's law, concentration or solubility. Solubility is equal to Kh into PO2. pH into pressure of partial pressure of O2. Okay. So as the gas is same, we are talking about the oxygen only, and temperature also same. Only thing we are changing the pressure from 1 atm to some other pressure. Okay. Partial pressure of oxygen is changing. Pure O2 means pressure is how much? 1 O2. 1. Okay, 1 atm. Is it understood? So when 1 atm is there, that was that time, what was the solubility? 43 mg per liter of water, pure O2, 1 atm. But I have converted into what? 760 torr. And we have to find out how much it is going to dissolve when it is mixed with the air. That means partial pressure is changing or not. So total pressure is given as 585. Total air pressure is how much? 585 torr. So and it is also given composition is 21.1 percentage. So total pressure into partial pressure, mole fraction, you will get to partial pressure. That is Dalton's law of partial pressure. So at 1 atm 43 mg, at this much pressure, what is the solubility? Is it understood? So this divided both KH will get cancelled. C1 by C2 is equal to P1 by P2. Okay. Now C2 is equal to C1 into P2 by P1. And what is C1 here? 43 milligrams. Take care. It is milligrams, and answer also while selecting the option, you should make sure that options are also in milligrams. Okay. So 43 into 123.435 divided by 760. So answer you are getting 7 milligrams. And I'm sure when this type of question came, the answer first A option itself was 7 milligrams, but answer is not 7 milligrams because I clearly told you it is asked for 500 milliliter. If 1 liter can dissolve 7 milligrams, so 500 will be just 7 by 2. So answer will be 3.5 milligrams. What is the answer? 3.5 milligram is the final answer. I think third question also clear. So this is the way you can learn when you go through the video solution, where the problem people are facing, and how much you should come to know which law we should use, at what place what we substitute, and why we are using. So if you're going through the theoretical solution from the book, you may not be able to understand that criticality. Okay. And I'm selecting the previous entrance question only. So better to solve every question on your own first, then cross check with the video solution. Okay. Okay. Now we are in the very different question, very different question, and appearing to be difficult, but if you understand the concept, easy question. Okay. Henry's constant for methane, molality of methane in benzene. So gas dissolved is methane, and gas into which it is dissolved is benzene, liquid. So Henry's law, we can use it. Okay. Henry's law constant. This is KH. KH units are mm of Hg. Okay. Determine solubility of methane. That solubility we have to find out under 760 mm of Hg. Okay. KH is given, P is given. Only thing what you have to find out, solubility we have to find out. Are you ready to go through it? Try yourself if and check your answer. Pause it here and check your answer with the video solution after certain time. Okay. Okay, this question was appearing very difficult, but if you see the solution, it is very easy. I think all of you must have solved and you have checked with the answer. Okay, here KH is given as 4.27 into 10 to the power of minus, sorry, 10 to the power of 5 mm of Hg. Mm of Hg. Units are most important, and you have to make sure that these two unit must be same. KH unit and P units both must be same, then only you will get the answer mole fraction which is unitless. So by God grace, and this question was prepared by one of the nice person in the world, he has not made any twist in the question, direct question, no twist question. Okay, so after seeing so many crime thriller twist questions, this is the easiest question. That itself is a twist. Okay, 760 by 4.27 into 10 to the power of 5. On simplification, you will get this answer. What is the answer? 170h into 10 to the power of minus 5 is the answer of this twistless twisted question. Okay, are you ready for the next question? Be ready. Okay, we are into the next question, the Henry's law constant. We are into the next twisted question. This is a twist question. The Henry's law constant for solubility of N2 in water at 298 Kelvin in 1 into 10 to the power of 5 atm. Okay, 10 to the power of 5 atm. Okay, then is the mole fraction of N2 in air is 0.8. Okay, and the number of moles of N2 from air dissolved. You have to find out number of moles of N2 in 10 moles of water. So moles of water already given. Moles of N2 you have to find out. And 5 atm pressure. What is the total pressure? 5 atm. But mole fraction is how much? Only 0.8. Okay. So out of 5 atm, what we have to find out? zero point 0.8 only belongs to that nitrogen. What will belongs to? zero point 0.8 part of the 5 atm only belongs to the partial pressure of nitrogen. To find out partial pressure of nitrogen, zero point 0.8 into 5, that is 4 atm is the partial pressure. Okay, so you try it now. I have given a hint, and check your answer after some time when you are getting solved. If you feel that I cannot solve, you can continue to watch, but what you have to do, you have noted the question, try to give it a try, pause it there itself, solve it. And if you're not able to solve, or if you're solved but wanted to confirm, then go through the solution. Okay. Okay, have you tried? Then check with solution. Okay, solution is Henry's law. P(n2) is equal to Kh into Xn2. P(n2) is equal to Kh into Xn2. But what we want here, the mole fraction we want. Okay, in how many moles? 10 mLs. Okay, so number of moles of N2 we want. What we have to find out? Number of moles of N2 we want in 10 moles of water. So for that, first we should find out mole fraction, and then we in the number of moles of N2 what we will write for 10 moles. Okay, so Xn2 will be for 1 mole of water. Is it understood? So Xn2 is equal to Pn2 upon Kh. Pn2 upon Kh. Kh is how much? It is Henry's law constant is 1 into 10 to the power of 5. Okay, and Pn2 is zero point 0.8 of 5 atm. zero point 0.8 of 5 atm. Is it understood? So what I will write, 1 upon 10 to the power of 5 into 0 0.8 into 5, it is going to how much? 4. Okay, what it is going to give you? 4. So indirectly what I can write here is 4 into 10 to the power of minus 5. 4 into 10 to the power of what? Minus 5. Okay, this is mole fraction. What it is? Mole fraction for 1 mole. Per 1 mole. Okay, but we want for how many moles? In 10 moles. Okay, so this is for 1 mole. So when you multiply it with 10, then answer will be 4 into 10 to the power of minus 4 moles of N2. moles of N2. What you have to find out? Number of moles of N2. Okay. These many moles of N2 will dissolve in 10 moles of water. Answer is 4 into 10 to the power of minus 4 moles of N2 will dissolve in water. Okay. So that's all varieties of questions covered. And I think all of you are happy. If you're happy with my teaching, just give a like and share it to your friends so that they should also be benefited. Stay with me, stay with CHEM, enrich your knowledge.